We now have different strategies that we can use to solve for missing sides and angles in triangles. If it's a right angle triangle, we can use Pythagoras' theorem or a primary trigonometric ratio. If it's not a right angle triangle, we can use either the sine law or the cosine law depending on the information that we're given. There's two other things we want to remember before we look at how to set up different problems using these concepts. The first is the angle of elevation compared to the angle of depression. If you think about the root word, we know that elevate means to raise up. And so if we start with our horizontal, so this is my horizontal line, I'm going to go up from the horizontal. And that angle that is formed when we go up, this here is my angle of elevation. If we're talking about angle of depression, if you're depressed, you're usually down. So we start again from the horizontal and we rotate down. So this arm is going to go in here, something like that. And this angle that's formed when we move that down is our angle of depression. So think about the root word. Elevation, we're going up. Depression, we're going down. When we're given an example, the first thing we always want to do is to try to sketch out what we know. In the first example, we ultimately want to determine the height of a kite. And remember, when we're dealing with the height, we can assume that we're going straight up at a 90-degree angle. So I've got my ground and I've got my kite up in the air here. We know that there are two people, Joey and Bob, who are 90 meters apart. It doesn't give us the heights of either of those two individuals, so I just represented them by little dots on the ground here. So one is Joey, one is Bob, and we know they're 90 meters apart. It says both of them are facing south. Now, that does not mean they're facing down into the ground, just like north is not straight up into the sky. That's how it's represented on a two-dimensional piece of paper. But what it means is they're both facing in the same direction. We do not have one person here and one person over here on this side. Okay, so they're both facing south. A clinometer is used to determine the angle of elevation. Now, if we take the sight line of each of these people, from the horizontal, we go up, and there is the first person's sight line to the kite. From the horizontal, we go up, there is the second person's sight line to the kite. Now, the two angles that we're given are 62 degrees and 37 degrees. Well, clearly on this picture, I can see this is my larger angle, this is my smaller angle. So that indicates that this smaller angle is going to be my 37 degrees, and this larger angle here is going to be my 62 degrees. And then I can fill in which is Bob and which is Joey, because I know that Joey has the angle of elevation of 62 degrees. So if this is my 62-degree elevation, that tells me that this person is Joey. So we can put a J there to represent Joey. And then Bob has to go here because his angle of elevation is 37 degrees. So go through the information first of all and see what is it that we know in order to set up the problem. And then I want you to actually pause this and see from there if you would be able to figure out the height of the kite. All right. In this right angle triangle, remember, other than the right angle, we need two pieces of information to calculate a missing side or angle. I know I have one angle here, which would allow me to figure out this angle here, but two angles alone isn't enough to determine the height, and I don't have another side in that triangle. So I'm going to need to figure out one of those pieces of information first. We have a second oblique triangle over here that also has a side length and an angle in it. So if I can use that to determine the length of their shared side, that would give me enough information to ultimately solve for the height. All right, so now the problem is we again need some information. I know this angle, but I do not know the side opposite from it. I have this side length, but I don't know the angle opposite. So we don't have enough information to use the sine law. I also don't have that pocket that would allow me to use the cosine law. So we're going to have to take a look and say, okay, is there anything else on here that we would be able to figure out? And we know that this is a straight angle here that forms 180 degrees. So if I already know that this is 62, what I can do to get that other angle is to say 180 degrees, subtract that 62 degree angle that we know, and that's going to leave us with 118 degrees. So I know that this angle here is 118 degrees. So that's the first thing we can do. And then we also know that 3 angles in a triangle have to add up to 180. So if I know those 2 angles, then we have enough information where we could find the third angle. So now I'm going to say 180 degrees minus that 118 degrees minus the 37 degrees we already have in there. That's going to give us an angle of 25 degrees. So then I know this is going to be 25 degrees. That gives me 2 pairs of opposites with only one unknown. There's my first pair of opposites. There is my second pair of opposites. So that I know I can use the sine law. If I'm solving for x, x is opposite that 37 degree angle. And then if I begin with a side length on top, remember we're going to continue with the side length on top. And the only side length we know in that triangle is 90 meters. So we're going to put 90 on top. And that 90 meters, this is the side opposite that 25 degree angle. So then we can set up the sine of 25 over here. And again, this is a proportion. So we're going to multiply the 2 diagonal from each other that we know, and we're going to divide by the other one. So in your calculator, make sure you're in degree mode. You're going to go sine of 37, close the bracket, multiply that by 90, press equals, divide it by the sine of 25. And when you do that, you're going to get a value for x of 128.161. And don't get rid of that because we're not finished yet. We want to keep the exact values until the end. You also can take a look at what we know about triangles. This is the smallest angle, which means the side opposite from it has to be the smallest side length. So that's good because this is smaller than what we have here. And again, nothing is drawn to scale, so just bear that in mind here. Okay, so that's the first part. Now the second part, we're back to grade 10 trigonometry with a right angle triangle. Given my reference angle, I'm looking for the side opposite. I now know the hypotenuse. So we know opposite and hypotenuse, that's the sine ratio that relates those sides. So I can just use a primary trigonometric ratio and say the sine of 62 is opposite over hypotenuse. And then again, remember that this 2 is a proportion. This is over 1. So you're going to multiply the 2 that are diagonal from each other, and then divide by that 1, which won't change your answer. When you go to do this, because this value is already in your calculator, I would just keep that in there and go times the sine of 62, and we should end up with a height of 113.2 meters, which again is not at all realistic. That's what we come out with given the situation, but this is not a very realistic problem. The next 2 examples already have diagrams drawn, and neither of them is a right angle triangle. So your only 2 strategies are going to be the sine law or the cosine law. I want you to pause this video again and see if you can figure out which of those 2 do you need to use to solve for the missing variable, and then how would you go about doing so. When you take a look at the first example, we can see that we have those pairs of opposites. These are the 2 that I know. These are the 2 where there's one unknown variable. That unknown I'm going to put in the top, and it is opposite the sine of 49. And again, because I started with a side length on top, I continue with a side length on top, and we know that 10 centimeters is opposite 63. So we're going to multiply those 2 values, remember to close the bracket, and then we're going to divide by the sine of 63. And if it doesn't specify, you can either leave this as an exact answer, or because it's a side length, I round it to the nearest tenth. Our second one here, this has that little pocket. So if we know the angle, and we know the 2 sides that contain that angle, we can use the cosine law. Now again, if we're looking for this side, make sure that that side is what we're solving for, which means that has to be the angle opposite from it. It's not difficult in this one because that's the only angle we're given, but sometimes they'll give you another angle in there as well. Okay, so I'm going to set this up, and I'm going to have one side squared plus the other side squared minus 2 times the first side times the second side times the cosine of that angle. You can enter this entire piece into your calculator exactly as is, and then remember that value is x squared. So to get just the value of x, we can square root, cancels the squared, and then do the same thing to the other side to keep your equation balanced. That brings us to the next example, where we also don't have a right angle triangle. So our only two options are the sine law or the cosine law. If you take a look at this one, we do have a pair of opposites, so that's good. But the problem is we're looking for y, and we do not know the angle opposite from it. This gives us two variables, which makes us unable to use the sine law. The cosine law is that pocket that we're looking for. And we know this angle, we know the one side, but the problem is we don't know that side. So we also don't have enough information to use the cosine law. In a case like this, you might have to back up and say, okay, we're going to need another piece of information. Is there anything else that we can figure out in here? Well, we do know that we have a pair of opposites here. This is my only other piece of information I'm given in this triangle, but I can use that to determine this angle opposite from it. So let's maybe take a look at that and say, okay, this is a pair of opposites. And so I can use that. And again, there's no letters at most of these angles. So let's just put a theta there. Because I'm looking for that angle, I'm going to begin with that on top. So I'm going to say the sine of theta is opposite from that 6 centimeters. And because I begin with an angle on top, I'm going to continue with an angle on top. And that is opposite from that 8 centimeters. When you put this in your calculator, again, we're multiplying the two diagonal from each other. So you're going to enter 6 times the sine of 76 equals, because we need to get that product before we divide by 8. And then when you divide by 8, remember that's going to give you that sine ratio. So we're going to have the sine of theta equals that ratio, and then we need to do that second function sine to take the inverse, and that will give us an angle of 46.69 degrees. And again, this is not ultimately what we're looking for, so I'm not going to round this off yet. I'm going to keep that value in the calculator and then continue on from there. Okay, so now we're ultimately looking for y, and I still don't have a pocket, and I still don't have a pair of opposites, but because I know two angles, I now have enough information to find that third angle. We know that there's 180 degrees in a triangle, so if I take away that angle we just calculated, and then if I take away that 76-degree angle, that's going to give us the remaining angle, which is going to come out to be about 57.304 degrees. So I know this is 57.304. I now have that pair of opposites. So again, leave that value in your calculator because we're not finished yet. And then we can set up the sine law. I'm looking for side y, which is opposite that 57.304 degree angle. I start with a side length on top, so I'm going to continue. And you've got a choice here in theory, because you now know this pair of opposites, you also know this pair of opposites. When possible, go with the pair given to you. If you happen to make a mistake here, everything that follows is incorrect. So I'm going to use the pair that was ultimately given to me in the beginning, and I'm going to put that side length on top. And then on the bottom, we're going to have the sine of that 76-degree angle. Again, this is already in your calculator. So when you cross multiply, we're going to go sine, second function answer to put that value in, times 8 equals, divided by the sine of 76 equals, and to the nearest tenth, because we're ultimately looking for y and we've now found it, we're going to have 6.9. Don't forget your units. In this case, it's going to be 6.9 centimeters. I know that the largest side length has to be opposite the largest angle. So in this particular question, this is my largest angle. That means this is the largest side length. This 46 is my smallest angle. So I know that this has to be my smallest side length. So we know that this value, because this is my medium angle, so to speak, has to be between those two. So you can just kind of check to make sure that everything checks out at the end. And the grand finale, our last example, we're looking for the distance between point A and point D. So that is A to D here. And AD happens to be opposite from side C. When you go to label this, we can use a C, but just be aware this is also opposite from angle C. So this is also side C. It's not a big deal in this case because this value is given to us, but sometimes if you have a situation like that, we just kind of use subscript to represent side C1 or C2 depending. All right, so that's what we're ultimately trying to find. Take a look at this and say, okay, can we use the sine law? Here would be our pair of opposites. This is the only other measure, but we don't know the angle opposite, so we can't use the sine law yet. Can we use the cosine law? Again, we're looking for that pocket. So we know this angle and we know this side, but we don't know the side of the other one. So we can't do that yet. We're going to have to utilize this other triangle to get a piece of information. And again, if we can ultimately find the length of this shared side, that would give us that pocket so we can use the cosine law. So let's go over here and say, okay, again, we want to clearly label everything because this is angle B. The side opposite, we want to try to stick to the letters we're given as much as possible. So I'm just going to label that side B. So make sure everything is really clearly labeled. This is a pair of opposites where I'm ultimately looking for B. Is there another pair that we have? Well, we know this angle, but we don't know the side opposite. And we know this side, but we don't know the angle. However, because we know these two angles, we can find that last angle. So let's take a look at that. Okay, so we've got 180 degrees in a triangle. Take off the 71 degrees, take off the 56 degrees that are given to us, and that will give us that last angle of 53 degrees. So I can fill in here, this is 53 degrees. We now have that pair of opposites. So I'm looking ultimately for B, which is opposite from the sine of opposite 71, so I can take the sine of 71. A side length that I know is that 105 meters, and again, that is opposite from the 53 degree angle. So when I put this in my calculator, we're going to go sine of 71 times 105, and we're going to divide by that sine of 53, and it gives us a B value of 124.31. And again, I'm not done, so I'm not going to round this off. I'm going to keep this. And then just quickly again do a check. This is my largest angle. That means this has to be my largest side length. It is larger than the one given to us, so we know we're kind of on the right track so far. All right, so now I can go to the cosine law because now I've got that little pocket. So I'm ultimately looking for the value of C. So I'm just going to do that C squared equals the one side squared. Now, because you have this in your calculator, I'm just going to go like that. We're going to square that. We're going to add it to the second side squared minus 2 times that first side times that second side times the cosine of that 43 degrees. And when you go to put this in your calculator, every time we're taking this value, you're always going to go second function answer to put that whole number in there. And when you do that, you're going to come out with the value of C squared, and it's going to be about 20,896 and so on. And then we're going to square root that to get just that value of C, which comes out to be 144.55. So again, if I'm going to round to the nearest tenth, which is what we tend to round side lengths to, because that number after the 10th position is a 5, that bumps up my other 5. So it becomes 144.6. And again, don't forget your units. In this case, we're working in meters, so we're going to put meters on there, and that gives us our final answer.